Second derivative test. So we have a function f of x equals to 1/3 x to the third minus 2x squared minus 5x plus 1. So for the second derivative test, the procedure is written in the second line. So first of all, we would need to find f prime and f double prime. So I clearly miss a prime right here. All right, so f prime of x, simple power rule, bring the 3 down, fraction is gone, you have x squared, bring the 2 down, 4x, and then 5, right? Derivative of 1 is equals to 0, and then you have to set this derivative equals to 0, and then you solve for x, right? So you have to set that equals to 0, and then you solve for x. So here is a factor. So how about this? X minus 5 and then x minus 1 equals to 0. Negative 5 times past 1 is equals to negative 5, and then 5 plus 1 is equals to negative 4. All right, so we have x equals to 5 and x equals to negative 1 as my critical numbers. Now, let me ask you a question. Does the domain of f affect the critical number? The answer is no. Take a look at the function. That is the third degree polynomial. X can be any positive, negative values you want, and x can be 0. So the domain of the given function is all real numbers. So that means 5 and negative 1, they are both critical numbers, right? And then the next step is we will have to find double prime. So that reduce the power one more time. So this is a 2x minus 4. Do we need to set this equals to 0? The answer is no, because we are not using the sign chart to study concavity. For the first derivative, we are not using a sign chart to analyzing the slope. So no sign chart at all. So what we are going to do next is we will have to plug in 5 and negative 1 to the second derivative. So f double prime, should I change to another color? Let's try this. So that gives you a color contrast. So f double prime, so when x is equals to 5, so what do we have? F double prime when x equals to 5, you have 2 times 5 minus 4, so that is 10 minus 4 equals to 6. So this is greater than 0. What does that mean? So here is the concept, the core concept of second derivative. You found 5 by setting the first derivative equals to 0. So that means x equals to 5 is a critical number. So it's a critical number, and then you set that equals to 0. That means there is a horizontal tangent line, right? So, and then critical number and horizontal line, then you are thinking this is either a minimum or maximum. And then when you test this critical number using the second derivative, they give you a positive, right? So they give you a positive. That means this is a positive. So that means it's concave up. What is concave up? Based on this point, we have a concave up. Then now you tell me, is this point minimum or maximum? The answer is this point, x equals to 5, is a relative minimum. What about x equals to negative 1? So when x is equals to negative 1, let's change to another color. So when f double prime, you test the negative 1, you have 2 times negative 1 minus 4. So this is a negative 2 minus 4, that is equals to negative 6. So this is a negative, right? Negative. What is negative second derivative means? Negative second derivative means concave down. What is concave down? You obtain negative 1 using the first derivative. You set that equals to 0. So that is like you have a point at x equals to negative 1. So you have a point. So this point is x equals to negative 1. And then that is equals to 0. That means there is a horizontal tangent line. And then concave down is based on this point. You build a concave down parabola. And then you have this. So is negative 1 min or max? The negative 1 is a relative maximum. Okay, so let me give you the picture. The picture is down here. So let me push this picture up, and then let me push these two screens up because I want to I want to discuss something in the graphing calculator. So in this picture, do we agree that when x is equals to negative 1, take a look, when x is equals to negative 1, we have a maximum. When x is equals to 5, we have a minimum. So how do we find the 3.66 and the negative 32? You have to plug it into the original function. So let's push this screenshot down, and then the very last step, you have to do a plugin. So what happened for function f? What happened when x is equals to -1? Let's do a 5. Let's do a 5 first. So when x is equals to 5, you have a 1/3 5 to the third power minus 2 times 5 to the second power minus 5 times 5 and then plus 1. So if you do this using your calculator, you get a -32.33, right? But okay, here is something you have to know. When you do homeworks online, I don't think they accept approximation. You have to give them a fraction. So and nobody wants to do a common denominator, right? Because it is so easy to make a mistake. And the second reason is most people are lazy. So if you don't want to do it, that's fine. So on your calculator, so here is where you have to go. You have to press the math key. Press the math key. And then after you press the math key, the first option is frac, right? F-R-A-C. So that means you convert the decimal to a fraction. So after you got your answer, just immediately go to math and then press the fraction. So they will set the answer to a fraction, and then they will give you that fraction. So -99.97 over 3. And then when x is equals to -1, so we do the same thing. We have a 11 over 3. So that means -1, 11 over 3. So this is a what? This is a maximum. And then the other one, 5 comma -97.3, this is a relative minimum. You have this is very important, that saves you so much time when you do this when you do an online homework or online exam. They only take fractions. I don't think they will take approximation. So this might save you maybe 5 minutes for doing some big numbers and some big common denominator. All right, so that is the end of this video. If you think my instruction is clear and helpful, give me a like. Feel free to share this video in any social media for me. If you are new to the channel, please take 2 seconds to click the subscribe button for me. I highly appreciate your help. I will see you all in the next lesson. Goodbye.